Hi everyone, we will be waiting 2 to 3 minutes before we get started to accommodate for the rest of the attendees who are in the middle of connecting. Stay tuned. Okay, welcome everyone. I'm Heike Ritter and I will be your host for this webinar. Thanks for joining and thanks for being part of our community. A few reminders before we start. This webinar is a recording which will be live streamed. We have our subject matter experts in the background to answer questions. The recording will be shared publicly afterwards and will be posted on our community at aka.ms/security-webinars. During the webinar, you can ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Usually questions you post will be made publicly visible, and if you prefer, you can post your question also anonymously by checking the box right below where you enter it. And as you can imagine, we often get many questions during these webinars, and we are really doing our best to respond to all of them in real time. If an answer was not provided, or if you have additional questions, you can go to our Microsoft 365 Defender TechNet forum at aka.ms/m365dtc to then spin up a topic and ask your question there. We love to hear your feedback on how we can improve these webinars, so please do so at aka.ms/security-webinar-feedback. This is really important so we can deliver the content you need. I posted all of those links also in the announcement section in the Q&A area, so feel free to click on those links. And then if you haven't already, please join our community at aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or make announcements. In our community, you can speak directly to the engineering teams that are building our security products. For Microsoft 365 Defender, you can do that again at aka.ms/m365dtc. And we believe that the best way to improve our products is by removing any barriers between you and the people that create them. So please join us. Today, I'm super excited to review how Microsoft 365 Defender can detect the various stages of Solorigate with Corinna Feuerstein and Christos Ventouris. So, and with that, let's go.
Hi, everyone. Welcome to our talk today. We are going to talk today about how to use Microsoft 365 Defender to protect against Solorigate. I'm Corinna Feuerstein. I'm a PM Manager on Microsoft 365 Security, and with me is Christos Ventouris, a Senior Program Manager on the team, and Jake Maurer, a Program Manager on the team as well. So, Microsoft security researchers are still in investigation and response to a sophisticated cyber attack that we name Solorigate. It's also referred as Sunburst by FireEye, and it involves a supply chain compromise and the subsequent compromise of some organizational cloud assets. While the investigations and impact assessments are ongoing, Microsoft is providing visibility into this attack chain and related threat intelligence for the Defender community as early as we can, so that organizations can identify and take actions to stop this attack, understanding the potential scope, and beginning a recovery process for this active threat. We have established a resource center where we constantly update everything we know about this attack, and this information is available at aka.ms/Solorigate. This talk today, paired with our Microsoft 365 Defender Solorigate blog that we published, serves as a guide for security operations and incident response teams for how to use Microsoft 365 Defender to identify, investigate, and respond to this Solorigate attack if it's found in your environment. The description of the attack in this talk is based on current analysis and investigations by researchers across Microsoft and our partners and the intelligence community who are all collaborating to respond to this attack. It's an active threat that continues to evolve, and so the findings here are representative of what we know at this time. And we continue to publish and update intelligence, indicators, tactics, techniques, and procedures at the location shown here. Before we dive into the actual attack, I would like to remind the audience a little bit about Microsoft 365 Defender. This is our security solution, a unified Microsoft 365 threat protection stack that comprises of the capabilities of 4 major product pillars: Microsoft Defender for Identity, Defender for Endpoint, Defender for Office 365, and Microsoft Cloud App Security. All 4 products are operating in unison under a coordinated cross-domain security capability. The activities that are provided in this unified experience include a unified portal for viewing attacks across the different product views, ability to provide coordinated protection from threats, automatic healing of affected assets, a unified threat intelligence and analytics section, and cross-domain threat hunting. And we will show today how to apply these different capabilities to an attack such as Solorigate, which we are discussing today. So let's move on to learn a little bit about the Solorigate attack. The Solorigate attack is an example of a modern cross-domain compromise. Since these kinds of attacks span multiple domains, having visibility to the entire scope is key to stopping and preventing its spread. It features sophisticated techniques involving a software supply chain compromise that allowed attackers to introduce malicious code into signed binaries on the SolarWinds Orion platform, which is a popular IT management software. The compromised application grants attackers easy deployment across a wide range of organizations who use and regularly update this application, with little risk of detection because the application is trusted. Then with this initial widespread foothold, the attackers can then pick and choose the specific organizations they want to continue operating within, while others basically remain an option at any point as long as the backdoor is installed and undetected. Based on our investigations, the next stages of the attack involved on-premises activity with the goal of off-premises access to cloud resources, and include the following parts. Using the compromised SolarWinds DLL to activate a backdoor that enables attackers to remotely control and operate on a device. Using the backdoor to steal credentials, escalate privileges, and move laterally to gain the ability to create XAML tokens using one of two methods, either stealing the XAML signing certificate from an ADFS server on-prem, or adding or modifying existing federation trusts. And finally, using those attacker-created XAML tokens to access cloud resources and perform actions that lead to activities like exfiltration of email and persistence in the cloud, which is the one seeming goal of this attacker. So now that we understand the general end-to-end model of this attack, let's drill in and see how we can use Microsoft 365 Defender to address this kind of attack. So as soon as the attack was discovered, Microsoft researchers published 2 threat analytics reports to help organizations determine if they are affected, assess the impact of the attack, and identify actions to contain it. These reports are published in Microsoft 365 in the Microsoft 365 Security Center. This is our portal at security.microsoft.com, and it's available to all Microsoft 365 Defender for endpoint customers and 365 Defender early adopters. In addition to detailed descriptions of the attack, TTPs, and the IOCs, the reports also provide real-time data aggregated from signals across Microsoft 365 Defender, indicating the all-up impact of the threat to the organization, as well as details about relevant incidents and alerts to initiate investigation. These reports continue to be updated as additional information becomes available. Now, given the significance of this specific threat, we are making similar relevant Microsoft threat intelligence data, including the updated list of IOCs, available outside of the threat analytics report and our 365 Defender portal to everyone publicly. And the comprehensive list of guidance and insights for that is available at the AKAMS/Solorigate URL. We recommend that Microsoft 365 Defender customers start their investigations here in the Threat Analytics report. After gaining deep understanding of the threat from the descriptions and getting the latest research findings, you can take the following steps. The report uses insights from TVM, which is the Threat and Vulnerability Management capability in Defender for Endpoint, to identify devices that have the compromised SolarWinds Orion platform binaries. And from this chart in Threat Analytics, we can view the mitigation details to see a list of devices which, with the vulnerability ID TVM 2020-002, which was added specifically to help with these Solorigate investigations. TVM also provides more information about this vulnerability as well as relevant applications in the software inventory view. And there are also multiple recommendations, security recommendations to address this threat, including instructions of how to update the software version that is installed on exposed devices. So this is our recommended first stop. for how to start the investigation and understand the general impact, if at all, of Solorigate in your organization. From the threat analytics report, you can quickly locate devices that have alerts that are related to the attack. But some Solorigate activities may not be directly tied to this specific threat in the system, but will still trigger alerts because of generally suspicious behaviors. And all alerts in Microsoft 365 Defender are correlated into incidents, which is an example of that you see here. Incidents help you see the relationship between detected activities. So they help understand the end-to-end picture of the attack, and also are the central place to start investigation, containing, and remediation of the threat in a consolidated manner. So the next recommendation is to review the incidents queue, looking for incidents and alerts relevant to this attacker's TTPs that are described in the threat analytics report we have seen before. Now, some alerts are specially tagged with the Microsoft threat experts to indicate that these are malicious activities that Microsoft researchers found in customer environments who are onboarded to this service during hunting. As part of this service, researchers investigated this attack as it unfolded and sent targeted attack notifications. So if you see an alert tagged with Microsoft Threat Experts, we strongly recommend that you give it immediate attention. In addition, Microsoft Threat Experts customers who have the Experts on Demand subscriptions can also reach out directly to our on-demand hunters for additional help in understanding this threat and the scope of its impact in their environments. Now let's talk a little bit about data. So Microsoft 365 Defender exposes all of the data collected from the various pillars and workloads in a hunting interface named Advanced Hunting. Advanced Hunting shows a very rich set of data sources. But in response to Solorigate, we actually enabled several additional data sources relevant for this type of threat, namely the Azure AD audit logs and Azure AD sign-in data. And this is now available for all customers in public preview. Azure AD audit logs are now available in the Cloud App Events table and provide the ability to see any changes done by features within Azure AD. Examples would be changes made to resources in Azure AD, adding or removing users, applications, groups, roles, and policies. Currently, this data is available to customers who have MCAS with the Office 365 connector. And going forward, we will be expanding availability to more Microsoft 365 Defender customers. The AAD sign-in logs are available in two new tables. They contain service principal and managed identity sign-in events in one table, and then interactive and non-interactive sign-in events in the other. These new tables are visible for global roles assigned in AAD only, as enforced by AAD. And they are currently suffixed with beta only because we expose them as quickly as possible as a short-term solution to help customers identify possible malicious sign-in events. But in parallel to making the data available, we're working on a more complete solution which may generate changes to tables and schemas for this data. And here's an example of how this data appears in Advanced Hunting and an example query for over this information about, in this case, sign-ins from of the same user from multiple cities. Now, we actually provided, in addition to these new data sources, a very comprehensive set of hunting queries relevant to the Solorigate attack. They are identified by the suffix Solorigate in our GitHub repository, and we will talk in today's talk about a few of them. We'll also describe some detections and hunting queries, but you'll see in the GitHub the full set of these hunting queries. With that, I will pass it on to Christos to start describing to us in detail how this attack unfolds and how we are able to see it in Microsoft 365 Defender.
Thank you, Corina. So in the first stage of the attack, we have the steps that involve the attacker getting initial access to the target organization and establishing command and control operations. So when the compromised SolarWinds binary gets loaded on the device through the normal update channels, the backdoor is activated and will go through an extensive list of checks to ensure that it is running in an actual enterprise network and not on a device of an analyst who would potentially try to reverse engineer or analyze the binary. It will then contact a command and control server using a subdomain that is generated partly with information gathered from the device, which means that a unique subdomain is generated for each affected domain in a target organization. The backdoor allows attackers to remotely run commands on the device and move to the next stages of the attack. For more information on the analysis of this stage, you can read our in-depth analysis of the Solorigate malware in the Microsoft blogs. With regard to detections from this stage, Microsoft Defender for Endpoint delivers comprehensive protection against this threat. Microsoft Defender Antivirus will detect and block the malicious DLL and its behaviors. It will quarantine the malware, even if the process is already running. For a full list of detections and protection alerts, you can also visit our blog. Now, if the malicious code is successfully deployed, the backdoor will lie dormant for up to 2 weeks, so that it will stay silent and blend, let's say, itself with the environment and not activate immediately, so that an organization will make the correlation that the malware execution was related to the update of the server. It will then attempt to contact numerous C2 domains, with the primary domain being in avsvmcloud.com, and the backdoor user is using a domain generation algorithm to evade detection. Microsoft 365 Defender detects and blocks this kind of behavior. To evade security software and analyst tools, the Solorigate malware enumerates the target system and is looking for certain running processes, loaded drivers, and registry keys with the goal of disabling them. The Microsoft Defender for Endpoint sensor is one of the processes the malware attempts to disable. Microsoft Defender for Endpoint has built-in protections against many techniques attackers use to disable endpoint sensors, ranging from hardened OS protection, anti-tampering policies, and detections for a variety of tampering attempts, including attempts to stop Microsoft Defender for Endpoint sensor or tampering with the settings of the endpoint sensor. Successfully disabling Microsoft Defender for Endpoint can prevent the system from reporting observed activities. However, the multitude of signals reported into Microsoft 365 Defender provides a unique opportunity to hunt for systems where the tampering technique used might have been successful. The hunting query that you can see in the slide can be used to locate devices that should be reporting to Defender, but they aren't. First, the query is setting up the lookup window to the last 24 hours and will check for devices that have not sent telemetry information for at least 8 hours. Then, a table containing all the devices with network activity is populated. After that, the query creates a table with devices that did have network activity in the last 8 hours, and a list of all the IPs with network traffic where network traffic is created. Then the query builds a table of devices with no network traffic, and a new list of devices seen active is created because they were seen by other devices running Defender. Finally, all the created tables are combined and summarized to show devices that were seen that were not seen sending telemetry for the last 8 hours, but they were seen communicating with other devices on the network that is protected by Defender. Now, after the attacker is establishing a backdoor connection on an affected device, the attacker's next goal is to achieve off-premises access to the organization's cloud services. To do this, they must find a way to gain permissions to those services. One technique we have seen the attackers use is to go after the organization's Active Directory Federation services, also known as ADFS server, to obtain the proverbial keys to the identity kingdom. ADFS enables federated identity and access management by securely sharing digital identity and entitlement rights across security and enterprise boundaries. Effectively, if we had to make a similarity to the Active Directory world, it is the LSAS for the cloud. Now, among other things, ADFS stores the security assertion markup language, also known as SAML token signing certificate, which is used to create authorization tokens for users or services in the organization so they can access cloud applications and resources after they are authenticated. To attack the ADFS infrastructure, the attacker must first obtain appropriate permissions through on-premises, through credential theft, intelligence gathering, and lateral movement. Building the backdoor described above, the attacker is leveraging fileless techniques for privilege escalation, persistence, and lateral movement, including evading analysis by using system binaries and exploration tools that masquerade as benign binaries. The attackers also carefully choose organization-specific command and control domains, and they use custom organization tool naming and locations to hide their activities. The next step in the attack is focusing on the ADFS infrastructure, and this can unfold in two separate paths that lead to the same outcome, which is the ability to create valid SAML tokens that will allow impersonation of users in the cloud. Now, the first path of the attack, after gaining administrative privileges in the organization's on-premise network, the attackers will enumerate Active Directory through the LDAP protocol and impersonate a domain controller to synchronize secrets and certificates information that lead to accessing the ADFS server itself. With access to the ADFS server, the attackers access and extract SAML signing key, and with this key, the attackers can create valid SAML tokens to access various desired cloud resources as the identity of their choosing. For the second path of the attack, after gaining administrative Azure Active Directory privileges using compromised credentials, the attackers add their own certificate as a trusted entity in the domain, either by adding a new federation trust to an existing tenant or modifying the properties of an existing federation trust. As a result, any SAML token they create and they sign will be valid for the identity of their choosing. With achieving this, the attacker has now transitioned from on-premise to the cloud, and they can continue their attack from there. Microsoft Defender for Endpoint can detect a wide array of these attack techniques, allowing SOC teams to track the attacker's action in the environment and take actions to contain the attack. Attackers collect data from Active Directory using a renamed version of the utility A-defined, running queries against domain controllers as part of the reconnaissance stage of the attack. Microsoft Defender for Endpoint detects this behavior and allows the SOC analyst to track compromised devices at this stage to gain visibility into the information the attacker is looking for. Here in this example, we can see how a suspicious LDAP query alert can show the exact LDAP query that was run by the tool. And we can also see that the tool that was used was actually a renamed version of the A-defined tool. To gain access to high-privileged accounts needed for later steps in the kill chain, the attackers move laterally between devices and dump credentials until an account with the needed privileges is compromised, all while remaining stealthy. Microsoft Defender for Identity will detect an alert of a variety of exploration and credential theft techniques. In addition to watching for alerts, security analysts can also hunt across identity data in Microsoft 365 Defender for signs of identities being compromised. Here is an example of a query that is looking for high volume of LDAP queries in a short time, filtering for non-DC devices. Now, the query starts by setting a time window of 1 minute and a threshold of 12 LDAP queries per minute. To distinguish legitimate from illegitimate DC traffic, the query creates an approximate list of domain controllers in the environment by looking for directory replication events between monitored devices. It then looks for LDAP queries from devices not in the domain controllers list and measures the rate of the queries based on the time window defined at the beginning of the query. If in the given time window the number of LDAP queries are exceeded, the device that exceeded the limit is listed in the query. Now, what should you do once you identify such devices? At this point, SOC teams can take containment measures within the Microsoft 365 Security Center, for example, using indicators to isolate the devices involved and block the remotely executed payload across the environment, as well as mark suspect users as compromised. Corina, back to you.
Thank you, Christos. So we will continue our journey here into this fascinating kill chain by talking about some of the next steps. So first of all, we've seen this threat execute a variety of credential theft methods, such as dumping LSSS memory, and those are also detected and blocked by Defender for Endpoint. The example here shows the detection of lateral movement with the attacker using WMI to run their payload remotely using the run DLL32 process. As you can see, run DLL32 is run remotely here and through WMI actually executing the payload on a different device, and by this essentially moving laterally to another device. Another technique used by the attacker for for persistence actually is WMI, event filter, and consumer binding. This is a technique sometimes used for persistence on a box. And again, you can see here, Defender for Endpoint detecting this advanced defense evasion and masquerading technique, which then is shown in the 365 Defender alert view. Normally, for every alert in the system, there are descriptions of recommended actions. This is the time to mention this and to recommend that anytime for any of the alerts that is shown here and you might see in the 365 Defender console, we recommend following the recommended actions in the alert to, in this case, remove persistence and prevent the attacker's payload from loading after reboot. So now we come to the step around the ADFS private key theft that Christos described to us before. And this is actually attacking the ADFS infrastructure, which can unfold, as we said, in two separate paths, but they lead to the same outcome. Which is the ability to create these valid XAML tokens that allow impersonation of users in the cloud. So the attackers may do this either by stealing the XAML signing certificate or by adding their own certificates as trusted entity in the domain. In this area, Defender for Endpoint and Defender for Identity both detect the actions that attackers take to steal the encryption key needed to decrypt the XAML signing certificate. Both solutions leverage unique LDAP telemetry to raise these high severity alerts, highlighting the attacker's progress towards this point of being able to create these illegal XAML tokens. For tracking changes to Federation Trust Configuration, which is the second method we described here, please see our advanced hunting query that we provide in the blog over the newly added AAD audit log data. Now, if the XAML signing certificate is confirmed to be compromised, first of all, let's see here also the, so we saw the MDE alert, and this is here the Defender for Identity alert, also alerting on Active Directory reconnaissance using LDAP, which suggests searching for the ADFS key. So if the XAML signing certificate is compromised or the attacker has added a new one, we recommend following the identity recovery best practices in an additional blog that is linked in the Solorigate collection, which will guide you in how to invalidate certificate rotation or invalidate the token through certificate rotation and prevent further use of it by the attacker. And additionally, affected ADFS servers may need to be isolated and remediated to ensure that no remaining attacker control remains. Note that this stage of the attack is critical. If the attacker gains the ability to create these forged XAML tokens, they can gain access to services or applications while basically bypassing any security checks, including multi-factor authentication. So to prevent attackers from gaining access to cloud resources, maximum investments are desired in preventing, discovering, and remediating this type of attack before this stage. Let's go over the final stage of this attack. Now that the attacker has access to the private encryption key in the first path that resides on the ADFS server, they can use the key to decrypt the signing certificate. The certificate can then be used to create these forged XAML tokens that, as we discussed. And for the second path, with the administrative privileges, they can add new certificates and as trusted objects. Now, with the ability to create these illegal XAML tokens, the attacker can now access sensitive data without having to originate from a compromised device or be confined to on-premises persistence. And the method of gaining access that we have observed is use of API access via existing OAuth applications or service principals. This way, they can attempt to blend into normal pattern of activity because these applications, or specifically using applications or service principals that normally have, for example, mail read or mail write permissions, and they may use them to read email content via Microsoft Graph or Outlook APIs. Now, if the application they choose to use does not already have read permissions for email, they can also modify the permissions of these applications and grant the application the required permissions. So let's see this part of the attack in the eyes of Microsoft 365 Defender. First of all, here in the cloud portion of the attack, Microsoft Cloud App Security, MCAS, comes into play. We have added a new detection of unusual credential additions to OAuth application. And this will alert the security team about applications that have been compromised to potentially extract data by identifying this unusual credential addition capability. This detection logic is built on anomaly detection that learns the behaviors of each user account or service principal in the environment and filters out normal usage patterns and ensures alerts highlight real attacks. If you see this alert in your environment and confirm that this is malicious activity, you should take immediate action to suspend the relevant account, mark it as compromised, reset the account password, and remove the credential additions. And you may also consider disabling the application completely during investigation and remediation. In addition to these alerts, we also have security teams can also use a few advanced hunting queries over the newly provided Azure AD audit logs to examine when new credentials have been added to a service principal or application. And here's an example of discovering the addition of uncommon credential types to applications through advanced hunting. Here we look in the Cloud App Events table. This is where the Azure AD audit log events are currently collected. And we look for events where the service principal credentials or certificate secrets may have been added or updated. And here we look for events where a password-based credential was replaced or replaced a certificate, or a certificate replaced a password-based credential. And finally, we display the affected applications with the difference in previous and new credential type set. Now, if the attacker is able to get to the final step of actually being able to read emails via the Graph APIs, we also provide a couple of hunting queries for identifying this capability or this activity. that would be performed in this case by those auth applications or service principals that have the mail read permissions and are used by the attacker, are abused by the attacker to perform this activity. These queries are based on increased visibility for this type of behavior, which is provided by the mail item accessed events that are now available in the same advanced hunting tables from Exchange, and they are exposed in Cloud App Events advanced hunting table. Note that if you have customized the list of audit events you are collecting, you may not be seeing these events, and so you may need to manually enable this telemetry so that you log these events. In the first query, again, we set a time frame and we look for potentially throttled mail read activity. So the system actually looks for more than 1,000 mail item accessed audit. If more than 1,000 mail access items audit events are recorded in less than 24 hours, then Exchange Online will stop generating them and present this throttling information. And the throttling behavior or the throttling information is a good starting point to look for potentially compromised mailboxes, because it means that there is a large volume of emails that were read all at once or within a short amount of time. And so we look for email access activities where auditing was throttled. In the second query, we look for auth apps reading mail through the Graph API and just search for some anomalies in this activity, looking for these applications whose behavior has changed prior to a baseline period. And so this query returns auth applications that are accessing user mail via Graph and did not do so in the previous week. Notice the first part here lists all the applications that used Graph API. This is the ID for that in a given time frame to access email, and then we compare that to activity earlier, a few days earlier, to see if there is a change in this type of activity that may be suspect. So in this talk, we have only presented part of the detections and hunting queries that are relevant to the Solorigate attack. You will see in the appendix of our blog, it contains a more comprehensive list of both all relevant detections across the Solorigate kill chain from across our Microsoft 365 products, across MDE, MDI, and MCAS, and a comprehensive list of our hunting queries that are relevant for this attack, and again available in our GitHub. So we encourage you to visit the blog for an updated list. We continue to update them as more arise. Now, there are a few more relevant blogs on Solorigate, some existing and some upcoming. We have the Analyzing Solorigate blog, which gives an in-depth malware analysis of the initial compromise backdoor that we just described here, but there is a lot more in-depth research type information in there, as well as our Advice for Incident Responders blog, which assists with guidance on how to recover, particularly identity compromised. And many of the Microsoft 365 Defender advanced hunting queries that we described here and are also in our blog can be used for activities that are described that are performed as part of the recovery. two more upcoming posts. There is one that will discuss the security admin aspect of this attack. So recommendations for how to improve the organizational security posture, meaning security configurations, hardening, and so on, relevant for an attack like Solorigate. We encourage you to watch for this. There's a lot of good information in there. And finally, there is an upcoming blog with a step-by-step guide on how to set up a lab on your own and simulate some of the Solorigate attack TTPs if you would like to do so. So this concludes our presentation. Again, we encourage you to watch for all of the information available from Microsoft about this threat, about our tooling, and anything that unfolds at AKAMS Solorigate. Learn more about Microsoft 365 Defender. And thank you for listening. Thank you, Christos.
Okay, thank you so much for presenting. And before we actually conclude the webinar, our next schedules are in February. Azure Sentinel, accelerate your Azure Sentinel deployment with the all-in-one accelerator. Then February 16, the billion-dollar central bank heist, and then February 18, best practices for converting detection rules from Splunk, Curator, and ArcSight to Azure Sentinel rules. February 23rd is Azure Security Center best practices for improving your secure score. And for more webinars and for details and registration, you can go to aka.ms/security webinars. Again, if we missed to answer questions or you have any additional questions, please go to our Microsoft 365 Defender forum at aka.ms/m365dtc. I posted all these links and information also in the announcement window. And again, thank you very much, Corey and Christos, for today's session. Thank you to the rest of the team who helped answering the questions. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you in the next one again, and goodbye.